Okay, so we started off with a lot of vocabulary here in 10.4 about the ellipses. So they define an ellipse as a set of all points P such that the sum of the distance between P and two distinct fixed points called the foci is constant. So what they mean is that the set of all points P just means any point P along this ellipse. Okay, so it can be any point, not just here. Now, they also talk about two distinct points. So there's two distinct points within the ellipse called the foci. Each point is called a focus, right? So they're the same distance from the origin. We'll just label those here. Alright, we have the focus. So the distance between P and each one of these, so let's say that we have this distance, we can call it D1, call this one D2, and when you add those together, it stays constant. It adds up to a constant, and as you move P along those two distances, when you add them together, they're always the same. So if we go to this website, you can see this actually point P moving, and this distance will stay constant. Okay. Now going back to these other points that we have, so the line, the segment that connects these two foci also intersects the ellipse. So this line is going to intersect the ellipse here and here too. And those 2 points will be called my vertices. So here's my first vertex, here's my second one. We'll just label those. And then that segment that connects these 4 points is called the major axis. Now the segment going perpendicular to the major axis is called the minor axis, okay? And then the points where the minor axis intersects the ellipse, those are called the co-vertices, alright? So the minor and the major axis are perpendicular to each other. So you can just draw that in right there. Alright, now, moving on. We have equations for an ellipse with a horizontal major axis and one with a vertical major axis. So here are the two formulas for that, and in each case A is always greater than B. So for the first one, now how does this translate to the graph? So for the first one, you see that we have x squared over a squared. That means on the horizontal axis, the x-axis, that each point, each vertex here is a units away. So whatever a squared is, for example, so here this is 6 units away. So say a squared was 36. That means a would be 6. So my first vertex would be here, right? And it would be point A0. Okay? And if you can guess, this one would just be what? It would be negative A0. And then same thing here, we have b squared, which is with y squared, so this is the minor axis. And let's say here we have 3, so say b squared is 9, then b would be 3. So 0, 3 would be my covertex, and then 0, negative 3, so the opposite would be my other covertex. Now, going over to the vertical major axis, here, looking at x squared, right, that's where, so say b squared is 4. That means b would be 2. So my first covertex would be at 2, 0, and then we would have it at negative 2, 0. And then my vertices would be whatever a is, take the square root. So in this case we have 1, 2, 3, 4, 5. So say a squared is 25, that means a is 5. So we would go up here, it would be 0, 5, and then 0, negative 5. Okay. Now, in order to find where the foci are located, what you need to do is subtract. So what you're going to subtract is, you're going to have a squared minus b squared equals c squared. So in each case, pretty much what you're doing is subtracting the larger denominator, subtracting the smaller denominator from the bigger one, and getting c squared. And then you just take the square root, and that'll tell you where your foci are located. So let's do some examples. Now, here, which one would be a squared? So the bigger one is always a squared. So this is a squared here. Alright? This is b squared. So what's a? If a squared is 36, then a would be 6. And then if this is b squared, b would be 2. Now, just look at what the numerator here is. If it's x squared, right, we know this is going to be plotted on the x-axis, so we're going to go over to 6, 0 right here, and then you're also going to go to negative 6, 0. Now, y squared, that's where your b is, so we're going to go to y-axis, go to 0, 2, and then negative 2, 0, and then we can draw our ellipse. Alright, let's just connect this. Alright, let's see if we can line this up a little bit better. Okay, that's about right. Now, if you want to determine what points the foci are located at, what you're going to do is, like I said before, a squared minus b squared, set it equal to c squared. So take the bigger denominator, subtract the smaller one, and set it equal to c squared. So in this case we have 36, right? That's our larger denominator, so we have 36 minus 4, and that's equal to c squared. What's 36 minus 4? 32. That's equal to c squared. And then to find c, which is the x-coordinate, in this case, of your foci, what you're going to do is just take the square root. So the square root of 32. So c equals the square root of 32. So that means my foci are located, so since the foci are here on the x-axis, it's going to be, the first one's going to be at radical 32, 0, right, so over on this side, and the other one's going to be at negative radical 32, 0. And these are my foci. Okay, moving on. So now let's go to one where it's reversed. So where's a squared here? A squared is the larger one always, so it's with y squared. So here's a squared, right? So that means a is 6. And now this is b squared, so b is 5. Okay, so let's plot these. So we're going to plot b. We're going to plot him with x, okay, on the x-axis. So that's how you can tell. So let's go to 5, 0 right here. Then we have to go to negative 5, 0. And now let's go to the y-axis. So that's where we're plotting a. So 0, 6. 1, 2, 3, 4, 5, 6. And then 0, negative 6. Okay. Let's draw this guy. Stretch him a little bit. Alright. Now, to find the foci, what you're going to do is bigger denominator minus the smaller one. So in this case we have 36, right, minus, oops, still on the ellipses there, 36 minus 25, oh, still on them, okay, 36 minus 25, and that's equal to what? C squared. Okay. Now 36 minus 25 is 11. That's equal to c squared. So c is the square root of these two things. So c equals radical 11. Now look, here your foci is always on the major axis, so your major axis is the y-axis now. So that means your points for your foci are going to be 0, comma, radical 11, 0, comma, negative radical 11. So here it's reversed from that last problem. So 0, because it's on the y-axis. And then 0, negative radical 11. Okay. Sorry, this is a bit sloppy. I'm using a mouse right now. Okay. Now, here's the next situation.